Here what we're looking at is very early stages of my prototyping process. I found a few of these prefab VEX parts on their website for various parts. Unfortunately, I didn't get a whole lot further than this because the prefab parts just weren't there as you start looking for more detailed parts. But this gave me an introductory. When I first started out, I had an idea of what I wanted to do. The basic chassis design, I was trying to figure out if the three-wheel design would work or not with what I was trying to do. Obviously, this is very different from what I ended up doing in the end. What my original plan is to have the line tracking. Obviously, these would be rotated to be parallel with the forward and backward axis of the robot. This line tracker here was going to be used for color sensing to drop into each individual bin, where I was going to tell with these limit switches if the can had went into the correct bin. This is very early design. I mean, obviously I was being very ambitious. I wanted to do a lot more than it really needed to, and it caused some slowdowns in the design process. But this is an interesting use of the VEX does have these prefab parts that you can go in and just import them into any CAD software. I'm using Autodesk Inventor. You can import them into SolidWorks or anything like that. They're just simple step files, and assemble them together in whichever way you need. And I even found that on the VEX website they have a can. That one of their games for one of the years involved a soda can, picking up a soda can, so that helped out with this for sizing and whatnot. So that's it. Looking at the project overview here of the assembly, we start with the main chassis. It's kind of similar to all the other chassis that I have built on previous robots. It's just more elongated because it needed more space on this robot, obviously, because the cans are so large. And I also needed a place to put the LCD screen. You'll see that I started with the base chassis. The wheel design was, I did this by parts, started with the chassis and then moved on to the upper body. And then the upper body consisted of the belt. That was my main drive to get the cans to where they needed to go. I didn't want to use bins because they were a little too bulky. I like the idea of the platforms with the rimmed edges. It allowed for the wiper to swipe fully onto them instead of running into the bins and having to lift it or something like that and having it be taller. I wanted it to be more flat than what it's supposed to be, or what it looked like there. The sonar on the front, it's built in a way that the claw does not interfere with it at all. Whether the claw is down or up, the sonar still reads perfectly fine. The only reason I had the claw up during driving was because of it helps with the stability of the robot. It helps not to tear the claw for some reason. If the claw were to get stuck down too far or something like that, it was pushing it into the ground. So what I ended up doing was I designed it in a way so that the line tracker and the sonar were all one big piece at the front of the robot, and neither one of them would interfere with each other, and the claw was all integrated in that system as well. It's a very modular robot. I could very easily take that entire claw system off and replace it with something else if need be. This is because I built it by parts and sectioned it out into each individual task of what it needed to complete. As far as gearing goes, the belt was going a little bit too fast with the main two-wire DC motor. What this ended up doing was causing it to have no friction between the can and the belt, because the coefficient of kinetic friction is smaller than static friction. So if the can is constantly sliding on the belt, it won't be able to move it very quickly up to the designated area. So I geared that down a little bit to make it a little slower. I did the exact same thing with the wheels. It was driving way too fast to be accurate at all. So I geared the wheels down and then did the same thing in the code to even lessen it even more. And that's pretty good overview of the robot design. There's a color sensor or a light sensor on the claw to detect the color of the can before it goes into the bins. And aside from that, the wiper is controlled by the motor that hangs over top of that, and like I said, the whole thing is modular, so it's all put together in large sub-assemblies, essentially, bolted onto one another, which makes it very easy to design it that way, as well as easy to put together. Okay, so this is the code for a Project 3, the Recycler robot. We start with the formalities, technicalities up here at the top of using and referencing the libraries that we need to run with the ultrasonic sensor and the various VEX parts, rather than the simple Arduino parts. And this is also used for the LCD screen and controller that's custom made rather than the general Arduino Uno. The Arduino we're using has a various shield on it that allows us to do the functions that we want to do with it. We then set up names for all of our motors. In my case, I had 2 motors for drive, as I went with a 3-wheel system, a left motor and a right motor, and then the back wheel system is a free drive. Then I had a motor for the wiper system, which swipes the cans onto their respective containers once it's placed on the belt. The claw motor is for, obviously, the claw. It opens and closes the claw for grabbing the can. The lift motor is what lifts the claw, and the belt motor is what drives the conveyor belt, which lifts the cans into their respective containers once it's placed on the conveyor belt. This here is just, again, formality, technicality for the LCD screen. Down here we have the sonar setup. The first part of the sonar setup is calling the name, then the input output pins, and the maximum distance that it should be measuring. So then we move into setup, and again we initialize all of the LCD. We move into initializing what we want the LCD to say at all times in certain places, and we write that down because we want to have values next to all of these. We then move into the attachment of the motors to their respective pins in the code, and this makes it easy so that if I want to attach the motors elsewhere, I can just change the numbers here. And as well, for all of the sensor pins, I knew that what I was going to be using, all of the pins besides the motors were going to be inputs. So in this case, I just decided to do a for loop for 0 to number 14 of the pins. Now this is all of the input pins. The input pins go up to 13, so if I do less than 14, it'll do every input pin, including 0. It'll make them all inputs so that if later I need to add in any more sensors, I don't have to go back and add another pin mode line of code to set that up. I can just use it as an input because it's already set up that way. We then move into the can function, which I use later as a reference function in the loop. This is so that if I need to change something in the can function, all I have to do is change it here instead of changing it in each individual time it's referenced. So going through the can function, we start by reading that line sensor, and when it reads greater than 100, it's black, so it sets it up a certain way, and When it's not, it sets the wiper up the other way. Once it sets up the initial wiper setting by reading the can, it knows what color the can is. This is the only thing you need to do to set up where the can's going to go, because the wiper acts as a guide as well as a finisher when it pushes it into the respective place. After setting up that and reading it, we move forward very, very slowly, inching toward the can to make sure that it's in the right orientation and position to grab with the claw. We then lower the arm all the way down to grab the can. We lift the motor, we drop the motor down and open the claw to the right position. We then close the claw down on the can, lift the motor up again onto the conveyor belt, and when the claw opens, the conveyor belt begins running upwards. The wiper is already in the right position, and the can is pushed into its respective bin. At the end of this, we add 1 to the can count so that we know how many cans we have on board. In the loop value, this is essentially the same code as it was for the line tracker robot. I'm using all the same values, the same line tracker setup, 3 line trackers, if-else statements, and the only thing I added in here was a reference to the sonar. So in each one, there's an if statement at the end of the drive function saying that if the sonar senses a can within 5 centimeters, but not 0 centimeters, which means that there's no reading, then it runs the can function, picking up the can and putting it into its respective bin. And then once it reaches down here, when the can count is 4, it does nothing, writes it forever, and the robot just stops until you reset it.
I'm pretty sure that's,
Finally.
Sure? Good question. What do I need to do?
Put it on the wrong side. Yep.
Here's the outread of the LCD screen. You can see as a line tracker. This is reading the line tracker values and outputting them onto the screen, changing whenever the line changes. What the X does is it counts the cans. Each time it senses a can close enough to it on the sonar, it adds to the count. And what you can see is, what you can't see here is that I also had it, when it went into the can function, it would change the screen to show what can it was detecting. Unfortunately, I didn't catch that on video, but it did have that in the code.